Electricity in a circuit.
This is a battery. The battery supplies all the energy that is needed to power an electric circuit. When the electrons pass through the battery, they pick up energy to take to the light bulb. The voltage of a battery determines how bright the light will glow. The more voltage, the more it will light up. The less voltage, the less it will light up.
This is a normal circuit. The battery is located at the top with a wire coming out of one side. The wire then leads to a light bulb, which is represented by the X. After the two light bulbs, the wire then leads back around to the other end of the battery to complete the circuit.
In a closed circuit, current is always flowing. Current is measured in amps and measured by an ammeter. The symbol for an ammeter is shown on the screen. If a wire has less metal atoms, then the current will be faster because the electrons have less to bump into. If there are more metal atoms for the electrons to bump into, the flow of them will be slower. In a restaurant, if there is a smaller path for the waiter to follow, then they will have to go slower so they don't drop the food. Then, when the path is bigger, they can move faster and deliver the food sooner. The bigger the wire, the smaller the path for the waiter. The smaller the wire, the bigger the path for the waiter.
The battery gives out a certain amount of voltage. This voltage affects how fast the flow of the current is, as well as the strength of the light coming from the light bulb. Voltage is measured in volts. In the case of a restaurant, the cooks can cook a certain amount of food. The more food that the cooks make, the faster the waiters have to deliver the food to the customers to keep running the business. Say a battery gives off 3 volts, then all the energy will be delivered to the light bulb, and the electrons will continue around the circuit, constantly keeping the light bulb at 3 volts of energy. The waiter will deliver 3 plates of food to the customers in a restaurant, and they will keep coming back to the different customers that fill the table and delivering them 3 plates of food as well.
Resistance determines how fast the electrons flow through the circuit. Resistance is measured in ohms. If you have the resistance set to a higher number of ohms, then the electrons will move slower through the circuit. If the food is cooked slower, then the waiter has to wait longer to deliver the food. And the food will be delivered later than if it was cooked at a normal pace. If the food was cooked faster, then the food will be delivered quicker.
This is an open circuit. No energy flows through it because the wires and light bulb are not hooked up to the battery. Without energy, the battery will never light up.
In a restaurant, when no one is cooking food in the kitchen, the customers aren't getting any food, so they are hungry. Without any food, they will always be sad.
There are thousands of electrons in each wire, and when they pass through the battery, they pick up energy to carry along to the light bulb. When the light bulb collects the energy, it will light up. Instead of thousands, there are about 20 waiters in a restaurant. Each waiter carries a certain amount of food, and they deliver it to the customers sitting at their tables. Once the customers eat the food, they are not hungry anymore. This is like the light bulb lighting up.
This is a series circuit. There is only one path for the electrons to flow. Therefore, all the electrons go to the same light bulb and go around doing the same thing each time. The waiter is assigned one table, and each time he or she delivers or takes food to and from that table, she follows the exact same route.
This is an ammeter. An ammeter measures the amount of electrons past a certain point per second. In our analogy, the cashier is the ammeter. This is because every time someone places an order, she can see how many pizzas are being made.
This is a resistor. A resistor slows the electrons down to reduce the flow of current in the wire. In our analogy, the resistor is the timer. This is because the pizzas need to cook, which takes time, meaning it slows down the circuit of the plates.
This is a voltmeter. A voltmeter measures the amount of voltage distributed by the battery. In our analogy, the chef is the voltmeter. This is because he can watch the food being made and the food left over. This is a parallel circuit. Parallel circuits divides the number of electrons up between how many light bulbs there are in the circuit. If there are two routes for the waiters to follow, then half of them will deliver the food to these customers, then the other half will deliver the food to the other customers. The voltage is split in half, just like the number of electrons. So once only half of the electrons are traveling towards one light bulb, then the voltage is half as much as when all the electrons were traveling out of the battery. So there will be half as much food traveling towards the second light bulb along the second wire. And when all the food was coming from the kitchen at the start, all the food was traveling along the same path to the customers. Resistance will affect all the electrons if it is placed along the path where all the electrons flow, but if it is placed on a wire where only half the electrons flow, it will only affect those electrons. If the path is smaller where all the waiters are walking, then they will all move slower. But if the path is smaller where only half the waiters walk, then only they will move slower.
This is the ammeter. This is the resistor. This is the voltmeter. This is another kind of series circuit. Instead of having only one light bulb, it has two. So there would be two tables for the waiters to work for. When the electrons pass through the first light bulb, they only give half of their energy. When they pass through the second light bulb, then they give off the rest of their energy. No matter how many light bulbs you can have in a circuit, the energy will always be distributed evenly by the electrons. In a restaurant, the waiters will deliver half the food to one set of customers and half the food to another set of customers.
This is the ammeter. This is the resistor, and this is the voltmeter. Thanks
for watching.
And we hope that you learned many things about electricity in a circuit.